not stationary. If this is stationary, then it's okay to apply differencing, just don't over difference. Okay, based on the reason, you can explain why. If this is already stationary, why you apply differencing? One of the reasons because you want to simplify equation without the mean. So that you want, let's say, you want to have a model that with mean. You don't want to use this equation and say, I don't want to use this equation. Difficult to write, for example. You want to have zero, non-zero mean, I want to have zero mean. And then one of us go in to apply for the differencing so that your C is going to be insignificant so that you can use one. Okay. So the first equation we have is data, employment data. So in the equation, if you apply both seasonal and announced differencing, and then you identify potential model by looking at this one. So I mean the data given, the open data. So this one, data for question number 1, Q1. Employment data. So this one, this part I leave it to you to do as homework to perform to inspect for the seasonal version. Okay, seasonal version. But if you look at the program, look at the graph, you can see it seems to have seasonal. Okay, and trend as well. And then you check the choreogram, labels. So you can see now in lecture12 smart data, in lecture12 you can see this kind of pattern. So the value of autocorrelation larger than the adjacent autocorrelation. So with that you can see that lecture12, 24, 36 and so on. So that gives indication that the series has seasonal variation. And then you go on to the test. And one also I leave it to you, I mentioned before. You form for this data, if you form your test, the series is, I mean, you look at the graph also, you can see that basically you can inspect the graph. It does not satisfy the two assumptions. First, the first assumption, the mean is not stable. So basically looking at graph also, sometimes we are able to know whether it's stationary or not. Yeah. So if you apply in your test, then the conclusion is that you need to apply, and the series is not stationary, so not stationary plus it has seasonal variation, so that we need to apply differencing, and then you are encouraged to apply seasonal difference because I mean it's different. Should be is advised to perform first. Okay. So to apply differencing, so you can do just like before. So you can use the component SD employ, and then you use the functional D bracket name, and then 012 for the difference. So you go to quick estimate, so analysis, quick analysis. Okay, this one, okay, you have to put a name. So this one is D. Okay, this one. Name, whatever name, it's up to you. But this one, you have to use this one. Okay. Okay. So you have seasonal differences. If you inspect the graph, just to have to see it. So basically, the mean, I'm not sure whether it's zero mean or non-zero mean, but in order to know that you can, when you estimate, you can put C and see whether it is good or not. So this one, if let's say, based on what I explained just now, you point the test, this one already, the first seasonal difference is already sufficient to make the series stationary. Okay, so that we can identify potential model by inspecting the colograms of this one, cologram of this seasonal difference series. So there is select level. Select level because we perform the test here on this series. Okay. Okay, so this one, if you identify the model, what model you can, for the, now let's say your large D equal to 1, small d 0, so small p and q, it is either, let's say you decide the maximum length allowed up to 6, okay, so you then inspect the first 6, so it is either, if you consider this as a certificate, then the last certificate, P is here, number 3, so ER3. ER3, A and A is A4, but basically this one, you see. So either MA4 and or AR3. How about seasonal one, seasonal component? Like 12, 24, 26, 12, 24, 26. So it is either SMA1. Okay, the one is significant. This one not significant. This one not significant. So SMA1 or SAR. Okay, there's no SAR, it's only significant. All significant, so I'm only SMA1. Okay. So we only have 2 potential model here. These 2. Okay. So you can estimate both and then you compare EIC and SIC, which one has high value. Okay. So you estimate, okay, now we can estimate both model. This is one. In R3 and SNE1. So this is how we write model. So this one, okay, so C certificate, you retain C. And then this one EIC, SIC. So you can, let's say, you name as equation 1, and then you estimate second model, MA4 and SNE1. And then you compare. So which one has smaller AIC, SIC? This one 4.7, 4.70. Oh, this one is smaller. 4.775. 4. And this one smaller. Okay. But you need to check whether to the aspect as well. You need to check whether it is adequate or not. So you check the residual, okay lah, residual okay lah, all greater than 0.05. So the model can be used. Okay, but just remember this model, it has C non-zero. So you want to write equation, then you have to use the correct equation. Okay. Now let's say we follow the equation. So let's say equation here we apply based on equation since we apply both different things. We apply both seasonal and non-seasonal difference. So I have one result so that after we apply seasonal and non-seasonal difference, we are able to have zero mean. Okay, zero mean. So if let's say we apply both seasonal and non-seasonal difference, and then after that you need to, you identify model by looking at, so you go to this one, SD, deploy diagnostic programs of the first difference. Okay. Let's say we apply both seasonal and non-seasonal difference, and then you identify potential model by looking at the programs of the differentiation, both seasonal and non-seasonal difference. So what model you can propose? So large D equal 1, small d equal 1. Small p and q, do we have small p and q? We don't have. Okay, all are insignificant. So you do not need, if it's all insignificant, no need to include. Okay, it's okay to only include seasonal part. Or it's also okay to only include the non-seasonal component if the seasonal component all are insignificant. Okay. So this one for the non-seasonal, ER and MA all are insignificant, no need. Okay, so P and P, small p 0, small q 0, and then inspect for the seasonal MA, AR, and like 12 to the 6, 12 to the 4 to the 6. So seasonal SMA 1 or SAR 2 or 3. 2 or 3. 2 what? 2 lah. Okay, this one is significant. This one not significant. So only this one. So SAR 2. So you can try this two lah. Okay, and then SMA 1 or SAR 2. If SMA 1 because monthly letter you put 12. SAR 2 because monthly letter you put 12 and 24. Okay, so estimate this one first. So this one before, okay. This one, question 2. So quick estimate equation. Okay, you put C, it's actually not significant. Okay, so you can take out so that because C, you can remove C so that you can use the simplified equation so that you can just use the equation given in the equation now. So you can use this one. Okay. So you check the invertibility, just like before, check our structure, it is invertible, residual, hologram. So residual all are p value except this one. Okay, but so because some of these less than 0.05, you need to perform the test at any particular leg. So this one just now when we estimate model, the included observation 83. The square root of 83. Around 9 So let 9 it is okay lah. Okay. Up. So we conclude up to displacement 9. We conclude that residual can be said to be why not process and the model is adequate. So this one model, equation 3. Okay, the last model, if let's say we try this one as well, this is R2. Okay, so this one you check for the stationarity. So SR2, okay, you put, okay, you see that although it's SSR, when we estimate, we put SSR 12, SSR 34, because monthly data, so SSR1 we put 12, SSR2 we put 34 for monthly data. But when when we click OK, it only appears as AR because if there is no, when we estimate if there is no non-seasonal AR, when the result only produce or appear like this, but this still correct, it is still correct. Okay, it is actually SSR1, SSR2. So you check the stationarity, it is stationary, residual, okay or not? Okay lah. Or greater than 0.5, okay, accept this one. So you have to form any particular line. This now I think it's going to be the same, like 9. So it is adequate model. So you compare both equation 3 and this one 4. Equation 3 just now. Which one is smaller? Yeah, I see. 4.82 is one. So this one has smaller AIC and SIC. So let's say we choose this one. So now to produce forecast using this one. To produce forecast using this model, you go to forecast. So just now we use data 1996. So you click forecast. Forecast, we have two options, whether forecast of the levels, forecast or forecast for the different cities. Okay, so of course we want to use forecast of the level. So forecast name, okay, let's say this one, KSE, SE for the standard error, and then forecast range 1971. 1971. First month to December. So the question asks you to forecast for the next 4 days. Forecast for January, April. And so maybe okay, follow that question. So just 0.4. Basically just the same. If you put 12, it just produce additional forecast values and up to December. But forecast for the first 4 months are still the same. Okay, so you forecast, point forecast as well as forecast intervals. So your forecast value are given here. Okay, 20, okay, next 4, and then standard error given here. So let's say you want to calculate the forecast manually, what you need to do. So you have to write down the equation. So this one is the justification for the model. So to write equation, we have seasonal dance difference in the difference, and then SME1. So you multiply, you get 1. So from here you can derive the forecast equation. So you refer to the estimated coefficient for SME1. So this one. So this one I need to do the calculation. I mean the Excel file provide the manual calculation. Okay. So you notice that the one that given here in the Word file, the answers is actually the value taken from e-views. But you calculate manually, you get slightly different. Okay. You can see that the one produced in Excel is slightly different. For example, for step head to 204, you calculate manually. Okay, but in e-views just now 203 or something, it's slightly different. Because of the rounding, decimal place. So you calculate manually. You have to use the identified question based on this. So if one step ahead, everything plus 1, 2 step ahead, everything plus 2, and so on. So this one residual. So you calculate manually like this. Okay. You based on the calculation. 1 step 8, 2 step 8, 3 step 8, and 4 step 8, and then SE, and then using SE you can calculate the Buka interval. Alright, question number 2. This one you get to see data as well. So this one, similarly, you form unit test, seasonal difference already sufficient to make this list actually. But let's say we want to have we want to have model with non-zero mean. So we want the model to have zero mean. So we decide to apply further differencing. So we apply both, and then we expect model. We expect the potential model. So this one, the previous one. So open the second data. So this one they say. So after we check, inspect the data, it has seasonal variation. It found to have seasonal variation, and then it is non-stationary. So we apply seasonal difference. So seasonal difference. So this one. So for seasonal difference, we have to create a variable by ourselves. So we cannot because in order to check, you test, then you have to perform the test on the seasonal difference. So we have, the use does not provide option to perform unit test on the seasonal difference. It only provide option to perform unit test on the first difference, second difference. So let's say data until October. Okay. So this one. So this one. If let's say you say that I want to apply referencing, then I just want to use this series, then you identify model by looking at the program of the seasonal difference. So what model kita propose? So large D1, small D0, large D1, small D0. So it is either MA1 or R1. Okay, MA1 or R1. This is the one. It is either SMA1 or SAR3. Okay, so the last significant one is 6. It depends on if you set a maximum order of 3, then you suggest R3. If you set maximum, you just allow maximum up to 2. I think if you not mistaken, maximum was only 2. Not mistaken, better we see now. Okay, if you select the automatic, using automatic model selection in the views, I think you can only up to order 2, not mistaken. The one we will do that later when we discuss the use of R. So we discuss the manual way first, then in the end we discuss the automatic model selection. How it is selected? Don't just use computer to select model for you. Just like you can use the ChatGPT, for example, to find answer for you, but you don't know how it is done. So this one, either NA1 or AR1, and then SMA1 or SAR3. MA1, MA1 and SAR3, MAR1 and SAR3 also can be considered. But here I just put 2. Okay. If let's say we want to have significant, this one we have an estimate. If you estimate C is going to be significant, let's say we take example this one, SME1 and SME1. So C significant, you have to retain C, and then you check residual. Oh, I see this one. All are insignificant, so that model is considered to be not adequate, inadequate. So you can use model. You have to consider other model. So second model given here as AR1 and SAP1. So how about this one? This one okay, huh? Yeah. Greater than 3.5. Another reason for you to apply for the differencing, although the series already stationary, is because the model the model that proposed by program is not adequate, so inadequate. So another as a solution, you can apply for the differencing by hoping that after you apply for the differencing, then you can find a model that is adequate model. Okay, now if let's say we apply both, because this one C is significant, so let's say we want to have C, we want one model, we want a model without mean, with zero mean. So we inspect the colograms of first difference. So meaning that we find colograms is not enough difference. Okay, so large D equal to 1, small d equal to 1, small p and q, it is either MA2 or AR3. AR4. Okay, and then seasonal one either SMA1 or SAR2. Okay, but here I just put one model. This one I select the one has based on parsimonious. Okay, so let's say we try this one first, MA2 and SME1. MA2 and SME1. Okay. So this one is not all model, you can add later. You can add other possible model, SAR3, AAR3, and then SAR2 as well, so that we included. Whenever we apply both frequency, seasonal and non-seasonal. So estimate model. MA2 and SME1, but we put 12 SME12 because it's monthly data. Okay, so you check whether the model is adequate or not. This one, C is not significant. You put C is not significant, so you can take out. You can remove C. So check residual. So it is okay. Model is adequate, so you can use to produce forecast. So to produce forecast, you go to forecast. So the name of the forecast series SE. So this one we estimate using data until October. So now we want to forecast the next 4. So it is 1996 November. November is 11. Okay, and then 1997 February to 02. Okay. So you have forecast values here, plus 4, and then your SE given here. Alright, so you want to calculate manually, then you have to write the forecast equation first. So we have both seasonal and non difference, and then MA2 as MA1, then you multiply that one, you expand, and then from here you identify the forecast equation. So one step 8, everything plus 1, 2 step 8. So you have to identify for the residual. For in sample, you can use residual. For out sample, T plus something, if T minus T and T minus something, you can just use the residual. Okay, for if T plus something, then just 0 lah. Okay, because we don't have residual for out sample. So again, this one also I need you to calculate. Okay, and you should be able to get this one. I mean, this one is taken from use. You calculate manually, it's slightly different. Slightly different. Okay, so this one. So I will provide you the example of calculation. Okay, forecast, point forecast, as well as forecast interval. So there is only one topic to discuss, the regression ARMA errors. How to use ARMA, how to apply ARMA on the error, on the residual error in order to, on the regression model, in order to make model better in terms of the autocorrelation problem, to fix or remedy autocorrelation. Because remember, this one, when we perform the test when we perform the seasonal budget test using regression, basically, if there is autocorrelation problem, the result is not that valid now. Okay, so it is good, it is better that if you fix the problem first and then perform after that you perform the test. So that one we discuss next week. Okay, so and then just remember week 14, you have to do quiz. Quiz. It will be given in week last week 14. And you can submit your assignment as well. Week 14. Yeah, I think that's all for today. So please do the part that I need to do. I need to do at home. The homework, try to perform your test so that you understand for the example given in the lab section 9, and then the calculation as well. Okay. students to do calculation. So this year there is a number of questions required to do calculation as well, but not as much as before, because the midterm test I already asked you to calculate. That's the reason the midterm test I calculate, because the exam has less calculation. Not compared to test, but compared to the previous year. Okay. There are a number of calculations, but not as much as before. Okay, see you next week.